So there is an interstellar object that has been flying through our galactic center, or coming from the galactic center, coming into our solar system. Now, this is very rare. Earlier, we had, I think it was called a Mamu, something to that effect. Looks something like this. I'm not sure if you guys have been paying attention to it, but it's very rare. I think they call it Atlas. What is it? Where's the name of it? 31 Atlas. First reported as an asteroid terrestrial impact blast alert system, survey telescope, Rio Horato, Chile. And that's it right here. Isn't that cool? If I'm not mistaken, it's only like a third object that we've detected. It's like the third object that we've detected coming from the galactic center, coming into our solar system from interstellar space. Now, it's strange because the object and the direction of the object, or at the very least where the object is going to come into, is going to come into our solar system. And it is going to make a very close connection to Mars, and even in relative distance to Earth. Now, many scientists have called this just an asteroid. They say, hey, this is an asteroid. Thing is, it doesn't entirely have the qualities or the quantities of a comet or an asteroid. It's very strange, it's very odd. And because it's very strange, very odd, from my point of view, it's just an anomalous object that has come into our system. Some people, however, have said that this is not just a comet or an asteroid, that it is so anomalous, especially in the direction that it's taking, that we maybe should count it as something else, meaning of alien origin. Now, from my point of view, that's pretty extreme. And look, I cover UFO stuff, right? I was a UFO person in my network. I've covered this stuff for decades at this point. This is within my wheelhouse of interest. This is a good depiction of it coming into our solar system. Might as well talk about it right here. That's the object coming from the galactic center, flying into our solar system at absurd, ridiculous speeds. I think it's, if I'm not mistaken, it's like 60 things a second. And that is it going up. But what I want you to notice, though, look at the trajectory. Look how close it's getting to Mars. That is astonishing. That is astonishing. Oh, my guest is here. Excellent. Avi, thank you for joining me, man. Let me bring you in. Thank you for joining me. I really appreciate it. I saw your thing. I often check my messages when I get very close to my time frame, because I'm not sure if my guest is trying to send me a message, and I just don't see it because I'm live. Yeah. Thank you for this.
Well, it's my great pleasure to join you, and I'll be glad to answer any questions you have about our new visitor from.
Excellent. And just so the audience would know, Professor Avi Loeb received PhD in plasma physics at the age of 24 at Hebrew University in Jerusalem, and was subsequently a long-term member of the Institute for Advanced Study in Princeton, where he started his work in theoretical astrophysics. In 1993, he moved to Harvard University, where he was tenured 3 years later. He is now the Frank B. Bard Jr. Professor of Science and former chair of the department. You have been getting a lot of press. You have been getting a lot of press. You have pissed off the physics community on this one. Why is this anomalous? Explain that to the audience for me, because it's fascinating that something is coming from the galactic center at absurd speeds through our solar system. But explain why the audience should care and be aware of this.
Yeah, well, thanks for inviting me. And first, I should say, we should keep our eyes on the ball. And what I mean by the ball is 3i Atlas. Because social media is all about virtue signaling, saying things about other people. That's irrelevant. This is an object that entered the solar system, the inner solar system. And it was noticed when it was 4.5 times away than the Earth-Sun separation. And it was discovered by a small telescope in Chile, 0.5 meter in diameter, called Atlas. And that's why it's called Atlas. And 3 means it's the third object from interstellar space. I stands for interstellar. So it's 3I Atlas. And what was striking, I mean, it was discovered on July 1st, 2025. And that night, I was actually interviewed by Coast to Coast. They asked me to wake up at 2 a.m. and someone emailed me that was listening to the interview, emailed me about this new object. And I looked up and it looked pretty bright because a small telescope discovered it. And then I calculated that if it's a solid object, its diameter needs to be 20 kilometers. That's bigger than Manhattan Island. It's twice as large as the asteroid that killed the dinosaurs, 66 million years ago. It's a huge thing. And the previous interstellar objects, Oumuamua was roughly 100 meters. Borisov was a few hundred meters. And there are hundreds of thousands of objects of that rocks of a size of over 100 meters for every object that is 20 kilometers. So how come we haven't found hundreds of thousands of Oumuamuas before we found 3I Atlas? So that didn't make much sense to me. And then we went, my wife wanted to go on vacation for July 4th. I was there and she went to the beach and I realized that I have to write a paper because if you take a 20-kilometer diameter object, rock, and deliver it to the inner solar system every few years, because this Atlas survey was going on for a few years, maybe 5 years, then there is just not enough mass in rocks in interstellar space to provide so much rocky material. It's just too rare. The chance of that happening is 1 in 10,000. Given the mass reservoir in rocks that you expect in interstellar space. So I wrote a paper about it, said, look, it can't be that large. It needs to be less than a kilometer. And then the reason it's bright is maybe because there is a big cloud of dust around it, which would mean that it's a comet. Alternatively, maybe it's not a natural object because maybe it was targeting the inner solar system. So you can't do these statistics. It's not an object that randomly came to the inner solar system. That last comment was one sentence at the end of my paper. The editor rejected that sentence. He said, we will not accept your paper for publication unless you remove any reference to a technological origin.
Really?
And I had no choice. Yeah, this is just like bullying because it's a matter of academic freedom. I would expect a sentence at the end of a paper to be completely legitimate. That's a possibility in case it's 20 kilometers in diameter. It just cannot be accounted for by the mass budget in interstellar space. And therefore, the logical conclusion is that it was not on a random orbit. It was targeting the inner solar system. But and this particular editor, Chris Lintott, from Oxford University, he also made statements, in the media afterwards, saying that imagining a technological origin is nonsense on stilts.
Why?
And
why is that
it's an insult to the good work being done by other astronomers. And I found that to be completely inappropriate and unprofessional because the way science is done is by asking questions and then answering them with evidence. It's not by bullying out of authority, saying something is nonsense and therefore should not be discussed. I mean, and what I'm saying is he used his power as editor to suppress a sentence at the end of a paper that he accepted for publication after the sentence was removed. But anyway, putting that aside.
But real quick, the sentence was honest because he doesn't know.
He doesn't know. And I can tell you that it's not only him. I mean, he definitely doesn't know, and he insists that it must be a rock. But the thing is, he not only believes in something which is completely legitimate, but he is extending his power as editor to suppress the ability of a scholar to mention this possibility. I'm not claiming it is. I'm just suggesting that it's a possibility in case it's 20 kilometers in diameter. That was taken out by his authority. It's using his editorial force to suppress free speech in academia. Okay? And he claims that he's protecting science. In my view, this is anti-science. The name is Chris Lintott, a professor at Oxford University, just so that you know. Now, After that, I decided, because this sentence was taken out, I said, okay, well, I'll write a full paper on this hypothesis. I'm the kind of person that I'm not giving up that easily. We're not in the Middle Ages here. So I wrote a full paper with two authors, Adam Hibbard and Adam Crowell, where we said, let's do an exercise, a pedagogical exercise, and ask, what is unusual about this object? Could it be technological? Okay. And we wrote a full paper on that, basically saying the trajectory of this object is extremely unusual. This object is arriving in the plane of the orbit of the Earth around the sun, and within 5 degrees. And the chance of that happening at random is 0.1%, 0.2%, very small. Moreover, suppose you say, okay, this trajectory was chosen by chance, okay, and it is in the plane of the planets, and then you randomly change the arrival time of this object, you find that only in 1 out of 20,000 cases it will come as close as it does to the inner planets like Jupiter, Mars, and Venus. It comes extremely close to them. You can see it from your play of this video, that it just gets at the right time, at the right place, to where Mars is and where Jupiter is and where Venus is. And the chance of that is 1 in 20,000. If it were arriving at different times, it wouldn't get there so close to these planets. Moreover, it gets closest to the sun when the Earth is on the opposite side. So we can't observe it. And the point of being closest to the sun is the point where a spacecraft would do a maneuver, because then it takes advantage of the force of gravity to do a maneuver. It's called an Oberth maneuver. It can slow down and visit and get bound to the sun. And we would not be able to see it at that point. So again, was this by design? And then it also came from a special direction, which is the region where the stars are very crowded. That's the center of the Milky Way galaxy, where it's difficult to actually detect it, discover it, because it's you would think at a large distance that it's one of the stars. And that's why it was discovered only on July 1st, 2025, when we have no chance of intercepting it with our rockets. It's too late now. When it moves close to the Earth, close to the sun, it would move at about 98 kilometers per second relative to Earth, because it comes in the opposite direction to the motion of the Earth. That's another choice, that it's on a retrograde orbit. The Earth moves one way and it moves the opposite way. So for us to launch a rocket to reach it, it would need to exceed by at least a factor of 3 the limit that we have on rocket speeds. We can't do it. And so the question arises as to whether this trajectory was designed, 0.2% to be aligned with the orbital plane of the Earth, and then 1 in 20,000 to arrive so close to the inner planets and to be on the opposite side of the sun from us, so we can't see it when it's closest and when it can do a maneuver. We said, well, maybe that was designed. Now, of course, one way to rule out this is to say, oh, it's a comet, and discover that it has a beautiful cometary tail. So far, the spectroscopic observations didn't find any evidence for atoms or molecules that are indicative of a cometary tail. The only thing that was discovered is that it's red. It reddens sunlight. And that could be a surface layer, because most of the objects in the outskirts of the solar system are red. They are bombarded by cosmic rays, by ultraviolet radiation. They develop organic molecules that gives them a reddish color. And this one is also red. It may be the surface. It may not be a dust cloud. We don't know for sure. There is a little bit of fuzz around the object. It doesn't look as sharp as the stars far away. But we don't see, usually comets have a beautiful cometary tail. That's the signature of a comet. We haven't seen it yet. It may well happen as it comes within a month or two close to the sun. I should say the most interesting thing I did was write a paper 2 days ago, submitted for publication, showing the fact that it comes so close to Jupiter is something we can take advantage of, because there is a spacecraft called Juno, which is right now parked around Jupiter. And we show in the paper that if on September 9th, we use the engines of Juno to give it some thrust, a kick, of 2.6 kilometers per second, which is potentially feasible if it has enough fuel to do that, the engine. And by the way, the plan for Juno was to fire the engine in the middle of September and bring it straight into Jupiter so that it finds its death. Because this mission started in 2011. It was supposed to end. When was it supposed to end? September 2025, 2 months from now.
Really?
Yeah, and I just noticed the amazing coincidence. Instead of firing it such that it will find its death in Jupiter, I'm suggesting firing it the opposite way, away from Jupiter, and then it will intercept the path of 3I Atlas on March 14th, 2026, when 3I Atlas gets closest to Jupiter. So I'm suggesting let's use Juno to get a better look at 3I Atlas on March 2026. I think it's a great idea. It's one way for NASA to get a lot of good press and to do something useful with a spacecraft that was about to be doomed exactly at the same time. Now, there are some members of Congress that might send a letter to NASA encouraging them to do that because just a couple of days ago, I spoke with Representative Anna Paulina Luna, and she was very interested. So I sent her all the details, and I hope there will be some request coming to NASA. It's not clear if NASA will do it. It's not clear if there is enough fuel in Juno. But my point is, even if there is not enough fuel left after such a long mission, let's just give it as much kick as possible in the direction of 3I Atlas and come as close as possible to it. That would be really interesting.
I am very, okay. You said that's not enough mass in interstellar space. Well, I guess two things. If this was an object, would it be a rock? Would it be rocky? Or
well, that's the natural assumption. That's what, if you ask comet experts, everything in the sky is rocks. They are still in the Stone Age where everything is stones. Everything is rock. Okay. So the simplest argument would be to say, it's a comet with a small nucleus, less than a kilometer. That's what I suggested as a solution to the fact that there isn't enough mass in interstellar space. So you might say, okay, well, the nucleus of this object is very small, less than a kilometer. And the bigger thing is the cloud of dust around it, as you have in the case of comets. That would be the simplest way to resolve the mass budget issue. But it will not. But then you have to admit that this comet just came in an amazing trajectory that is aligned with the plane where all the planets are orbiting the sun. It just comes in that plane so it can get a good look at Mars, at Jupiter, Venus, and the diagram you showed illustrates that, because these planets are, moving around. Right. And why would it arrive exactly at the right time at the right place to be close to all of them, and also be exactly on the opposite side of the sun when it comes closest to the sun, when we could observe it? I just don't know. I think it's worth monitoring it. And in general, I wanted to encourage my colleagues, the observers, to take as much data as possible about it, because then it would be impossible to shove all the anomalies under the carpet of conventional thinking. That's my point, is that if the Vatican, instead of putting Galileo in house arrest, if they were to say, okay, we'll prove him wrong by looking through telescopes,
right,
they would have realized that he's right much earlier if they did that.
We don't have the capability of, God, man, this shows how big space is. And to back your point up on this, you're absolutely right. Scientists shouldn't. Sabrina Hoffens, jeez, I always have a hard time saying her name, Hassenfelder, gave you a very good compliment.
Yes, Sabrina.
Thank you.
Yeah, right.
Yes, she's a fantastic channel.
Did she say something about this object?
She did. She pointed out.
By the way, she's not a practicing physicist. She popularizes science, but she's not doing. Yeah,
but she's very good though. And
she
pointed out.
What did she say?
She effectively said that this is an idea that people can discard this. It's nonsense. It's impossible to know. It's
right. I mean, I can give you an example. There was a paper written by comet experts just a few days ago, where they took a spectrum of this object, and the title says, oh, we found evidence for water ice. That was the title. They discovered water ice in this comet. They know it's a comet, and they know it has water ice. You look at the paper, you look at the data. So they show the intensity of light from the object as a function of wavelength. That's called the spectrum. Right. And it's very jittery. You know, like there is a lot of noise. The intensity goes up and down as a function of wavelength. And then they show various possible fits to the data, one of which is an L-type asteroid, you know, just an object that with a surface, okay, a rock with a surface, which goes very nicely through, in the upper envelope of possibilities, it goes very nicely through this fluctuating data. And then they show an example where they tuned the water composition to be 30% and 70% rock. And then it shows some features where, you know, the intensity of light goes down at some wavelength and then goes up at some wavelength. And they claim victory. They say, oh, this model does excellent. Now you look at where it goes down, confirmation, and actually the data goes up at that point. Right. And then you look at where it goes up, the signal supposed to go up, and then the data goes down. And they just say, oh, it's a great fit because the intensity goes up and down all the time. So it's just wishful thinking. Now, what is often done in science is you need to compare the model that you think is your favorite to the data and show that the deviation from the data is less than for other models. That's what you should do. You should look at other models and show that quantitatively they do a worse job at fitting the data. But what I'm saying is if you take the upper envelope of L-type asteroids, which have no comma, you know, it's not a comet, it's just a rock, you get, in my view, a better fit by eye to the data that goes up and down, because the data goes up when the signal of water should go down and vice versa. So, and yet, this group of people went to the press, wrote at the title of their paper, we found the water ice, went to the press and said, confirmed, water ice. And it just shows you how much cheating is going on, because you just look at the spectrum, it shows nothing.
Well, they have an ideology. Like, look, I am not one of those people that believe scientists are free of human ideological
biases.
Yeah,
well,
exactly.
we all know that because during COVID-19, the claim that there were gain of function experiments in the Wuhan lab was dismissed as racist, right. As the origin of the COVID. I mean, we knew that there were experiments on SARS type viruses there, and why is that racist? It's just a possibility that has to be entertained, and nowadays it's much more considered as a real possibility. I think it's really unfortunate that many scientists have an agenda, as you say, and sometimes the agenda is cultural. It's about virtue signaling to some constituency, or most of the time it's just reclaiming that the traditional thinking is correct once again, while dismissing any deviation from
I know,
that.
but this is not traditional thinking on this. I mean, the scientific point of view, you would think would be, we don't know what this is.
Yeah.
It may be a comet. It may be an asteroid.
Exactly. Let's collect more data. Let's collect more data.
Why do you think they exclude this idea of, because look, your point of view, I accept this idea that, okay, this thing is, if the people on the channel ever get to see the real way that the galaxy moves through space, it's this kind of corkscrew thing. It's not like everything is just standing on an even level. It's like it's on an even level, but within the context of corkscrew. It is very weird for something to come out, especially only the third object, and to come through our solar system in the way that it's coming through. And yet they're like, no, it's impossible that it's technological. It's like, well, why is that impossible?
Yeah, why? What do we lose by being open-minded? That's my question. Why not just get as much data as possible? And if you think that it's wrong, one hypothesis is wrong, just prove it by data, not by ridiculing, not by asking the author to remove a sentence and by that claiming the victory. That's not the approach that science should take. To me,
we don't have the ability to see this. By the way, I'm sorry to interrupt. We don't have the ability to see this, where we like telescopes, things in space.
Of course we have. And the best telescopes will look at it in the coming months. The only time when we can't look at it from Earth is when it gets closest to the sun. That's one of the coincidences. We won't be able to observe it when it's within 30 degrees of the sun, because the telescopes will burn up if they look that close to the sun.
I see.
So, my point is that science is all about asking questions, and no question should be ridiculed. We should find the answers by seeking the data. That is the method of the scientific method. And what you find is that people who call themselves scientists, I mean, you see how much prejudice they exercise, and part of it is because the public cares about it. Okay, so the public cares about it. Does it mean that we shouldn't discuss it? By the way, many of these people who ridicule, denounce it, are people who are not active scientifically. There was a guy that posted something on YouTube, and he's not even, he didn't get a job in academia. He's not a practicing scientist. I wrote 9 scientific papers, 9, just in the month of July. I wrote 9 scientific papers on the archive where preprints are posted. In addition to that, I communicate the work that I'm doing. I wrote 20 essays on medium.com, mostly about this 3i atlas. But the point of the matter is, I'm in the trenches doing the science, and then these non-scientists who didn't write a scientific paper in a decade, I'm not talking about yesterday or last month, in a decade. I wrote 9 last month. He didn't write anything over a decade. You know, these are the ones who are claiming to protect science. Who are they protecting it from? From people who practice science? That's completely ridiculous. A guy that has no job in academia, is not pursuing science, just appearing on YouTube or writing blogs, that's the guy that is supposed to protect science against someone who is practicing science.
He writes a blog, Avi. He writes a blog. he writes stuff on Twitter. He writes stuff on Twitter. That's his thing. I'm curious on something else. You invoked a terrifying premise in an interview that you gave, where you mentioned dark forests. Now, dark forests, Letitia Liu's 3-body series, one of the best series of books, but God, it's terrifying.
Yes.
And the fact that you evoke dark forest is like, oh God. With the audience, okay, so for the audience, just so they know.
But by the way, Xixing Liu at some point reached out to me through his agent, and
did he?
Because Netflix was considering making a series about it, and
what they did,
yeah, and Netflix consulted with me, and I said that would be a great thing for you to do, and they did a fine job, but let me explain that. So the dark forest hypothesis is a solution to Enrico Fermi's question, where is everybody? And the idea is that aliens are everywhere, but they are silent because they're worried about predators. And those that were loud, were destroyed. So it's a matter of survival. And one of the most...
Just interrupt. Destroyed casually. It's not out of malice. It's not out of anger.
By the way, we're talking about periods of, millions, billions of years. When I say destroyed, it's not instantly, okay?
Yeah.
Now, it's possible that we are being monitored, that there might be spacecraft parked in the outskirts of the solar system, maybe even at 1,000 times Earth-Sun separation. We can't see them even if they're tens of kilometers in size, because they don't reflect much sunlight. They're completely, they're very faint. With our best telescopes, we can't see them. So if there is something parked not far from us, it would take 3i atlas. It took 3i atlas about 8,000 years to arrive from 100,000 times the Earth-Sun separation. It would take it 80 years, less than a century, to arrive from 1,000 times the Earth-Sun separation, which is pretty much the largest distance at which we can see any object, as big as, Planet 9 that is being discussed, big as 5 times the mass of the Earth. We barely can see it. But here we're talking about like a much smaller object. Obviously, we can't see it. So it would take just 80 years from 1,000 times the Earth-Sun separation, like that over the past century. So if they're listening and they monitor what happens on Earth, we just don't know that they're out there, and they detect. We are completely careless. We are transmitting everything, like broadcasting everything that happens here. And at some point, they might realize that we are a young technological civilization on the path to being a threat to them. Okay, so at that point they might visit us. And my point is, we should, now that we are in the mode of detecting interstellar objects, the Rubin Observatory in Chile, every few months is expected to find a new interstellar object. We should just check whether each and every one of them is natural or artificial. Why should the editor of a scientific journal dismiss that possibility upfront and say we shouldn't discuss it? That, to me, is not a sign of intelligence.
Avi, I agree with you. I agree. I am hoping we're not in a dark forest. Oh, Lord knows I hope we're not. That book is terrifying. It's like this existential horror, even though it's scientific triumphalism in a book form, but it's terrifying when you really think about the premise.
But we have no choice as to who is our neighbor. When you live you buy a house on the street, you just can't remove the neighbors that you have. So we see a lot of houses in our streets, Earth, Sun systems. There are billions of them in the Milky Way galaxy. And my colleagues argue, they might not have any residents, that don't worry about it. And I say, well, wait, if we see someone in our backyard, we better check, so we have it's not, people can ridicule ideas on social media and get very arrogant about their view being right because they have a lot of likes. But that would not change who our neighbors are. For the same reason that the Vatican putting Galileo in house arrest didn't change the fact that we are not in the center of the universe. The Earth moved around the sun for 4.5 billion years before the Vatican put Galileo in 4.5 billion years. They put Galileo in house arrest as if that will change the situation. Obviously, it didn't. So who cares what the Vatican says? Who cares what an editor of a scientific journal says? It's completely irrelevant. The reality is whatever it is. And the only way for us to figure it out is to collect as much data as possible. That's what we should do. Now, what humans do very often, quite effectively, like the Vatican or this editor, they have an opinion, okay? So they suppress the collection of new data because they know the answer in advance. That's a recipe for maintaining your ignorance. That's a recipe for dictating the answer to yourself, but obviously not changing reality. And I say, if we want to behave as an intelligent species, we should not assume that we know the answer in advance, but search for it by collecting data.
Avi, you're awesome. You're awesome. Avi Loeb, Professor Avi Loeb at that. He received a PhD in plasma physics at the age of 24 from Hebrew University in Jerusalem and was subsequently a long-term member at the Institute for Advanced Study of Physics in Princeton, where he started work in theoretical astrophysics. In 1993, he moved to Harvard University, where he was tenured 3 years later. He is now Frank B. Bard Jr., Professor of Science and former chair of the department. Avi, keep kicking ass. You have a good one, man. Thank you for this.
Thank you. Bye-bye.
Bye-bye.